Welcome to our presentation on the cloud control matrix and the security implementation best practices for the cryptography, encryption, and key management domain in the cloud control matrix. My name is Kerry Steele. I'm a principal in the payments and cloud advisory practice at Coalfire. I am certified as a CISSP, CCSP, CISA, CDPSC, ISSAP, and PCI-QSA. I joined Coalfire's compliance advisory practice in January of 2022, bringing to the team over 25 years of experience across multiple security domains, including network security, application security, and cloud. Akshay?
Hi, my name is Akshay Bhardwaj, and security business lead at Sprinkler. I joined Sprinkler 2 years back as a security business lead, focusing on cloud and product security and supporting customers with their security requirements. I have extensive experience in security analysis, secure product design, communicating complex security concepts. And today I'm excited to share insights on cloud security, best practices that can help business innovate securely in a rapid evolving digital landscape.
Thanks, Akshay. Let's dive right in. Our agenda today, we're going to cover 5 key areas. Provide a quick overview of the Cloud Control Matrix version 4. We'll describe the cryptography, encryption, and key management, or CEK, domain controls. Describe the CSPs and CSCs, a shared security responsibility model. And we'll discuss some of the security implementation best practices for the domain, CEK domain. And finally, we'll wrap up with some of our final thoughts.
Great outline, Kerry. Let's start with the Cloud Control Matrix. What is Cloud Control Matrix, and why is it so crucial in cloud security? The Cloud Control Matrix is a comprehensive framework that truly unique in its approach. It's a result of extensive research driven by a group of stakeholders that includes cloud consumers, providers, and assurance professionals. This collaborative effort ensures that the CCM addresses real-world needs and challenges in cloud security. One of the key strengths is its ability to simplify complex processes. It provides a streamlined approach to implementation, assessments, and compliance across all the cloud environment. Whether you are dealing with public, private, or hybrid cloud, the CCM offers a consistent methodology. Importantly, the CCM doesn't exist in isolation. It carefully aligns with the map to the global regulation and the most relevant security frameworks. This alignment means that when you are working with the CCM, you are simultaneously addressing requirements from multiple regulatory bodies and industry standards.
Absolutely, Akshay. And a critical feature of the CCM is how it defines security responsibilities through the shared security responsibility model, or SSRM for short. It clearly defines which security responsibilities fall under the cloud service provider's purview, which controls the customer's responsibility, and which controls are shared between the provider and the customer. This clarity is invaluable in preventing gaps in security coverage. The CCM is also remarkably flexible, provides applicability guidance for different cloud service models, including software as a service, or SaaS, platform as a service, PaaS, and infrastructure as a service, or IaaS. This means you can apply the appropriate controls that are tailored for your particular cloud service model.
Lastly, it's worth noting that the CCM serves as a backbone of the CSA STAR program. This program is widely used to assess and compare cloud service providers, making the CCM an essential tool for both providers and customers in the cloud ecosystem. Let's see what CCM framework components provide and their significance in the industry. The CCM brings an invaluable set of tools to ensure best practices are applied across cloud environment. At its core are the CCM implementation guidelines designed to help organizations effectively to implement the control specified in the CCM. These guidelines offer detailed recommendation and structure guidance for each control, ensuring that both cloud providers and consumers can navigate the CCM control properly. A crucial component of the CCM is the SSRM. These implementation guidelines clarify the division of security responsibility between cloud service providers and cloud service consumers. It's essential for ensuring that both parties understand their roles in securing cloud environment, thereby reducing the risk of security breaches due to miscommunication or misunderstanding. Another tool closely aligned with the CCM is the Consensus Assessment Initiative Questionnaire, or in short, that we like to call is CAKE. Provided by the Cloud Security Alliance, the CAKE helps organizations assess the security posture of CSP, complementing the CCM framework.
Thanks, Akshay. Let's take a quick overview of the CCM version 4 security domains. The CCM version 4 comprises 17 security domains and 197 controls across those domains. These domains include identity and access management, threat and vulnerability management, and other domains that offer a holistic approach to cloud security, addressing three key aspects. Number one, the control applicability and ownership, clarifying who's responsible for each control and which are shared. Number two, architectural relevance, ensuring controls are applied consistently across all cloud security stack components. And third, organizational relevance, aligning security with organizational structures and processes. This framework can be tailored to any organization's needs, regardless of their size or cloud deployment complexity. As we move forward in the discussion, we'll dive deeper into the CEK domain, exploring how these principles apply specifically to cryptography, encryption, and key management within cloud environments. So let's dive into the CEK domain specifically. Akshay?
Yes. Moving on to our focus area, let's discuss the cryptography, encryption, and key management domain, or CEK. This domain consists of 21 control specifications that apply to the entire lifecycle of protecting customer data, using cryptography techniques, encryption, and key management services provided by the CSP. The CEK domain defines control for people, process, and technology, and we have further divided these 21 controls into three main categories for ease of understanding that you will see in the next slide. An important aspect to understand is shared security responsibility model between CSPs and CSCs. CSPs are responsible for the security of the cloud, providing capabilities for secure data storage, access, and disposal. CSCs, on the other hand, are responsible for security in the cloud, protecting the data they store or process in the cloud by leveraging the CSP's provided capabilities for data protection. Now that we have covered the CCM framework, let's focus on categorization of CEK control. Can you walk us through the CEK controls that we have categorized?
Certainly, Akshay. The CEK domain consists of 21 controls, which are divided into three main categories here. These categories cover the entire spectrum of cryptographic operations in cloud environments. The first category, data encryption, includes controls for data encryption and specifying encryption algorithms. The next category, policy and governance, covers crucial areas like encryption policies, roles and responsibilities, change management, risk management, and auditing. Lastly, the key lifecycle management category includes controls for key generation, rotation, revocation, destruction, and capabilities for customer key management. And lastly, key inventory management. This ensures organizations keep track of all their cryptographic keys throughout the lifecycle, throughout their environment.
Thanks, Kerry. It's clear that these controls provide a comprehensive framework for managing cryptography in the cloud environment. Let's move on to how these controls are implemented in practice. Let's discuss how these responsibilities are shared between CSPs and CSCs. Because it's very crucial in practical terms, the CEK control help both parties protect relevant data and comply with data protection laws and regulation, but there's a clear division of responsibility.
Absolutely. The CSP is responsible for security of the cloud. This means they provide capabilities for secure data storage, access, and disposal. And on the flip side, the CSC is responsible for securing the data that they store or process in the cloud. This includes classifying data and leveraging the CSP provided capabilities for data protection.
Exactly. And understanding shared responsibility is critical when protecting the data in the cloud. As you can see, the right side, we have a table here showing the control ownership by service model. And under each service model, you can see some alphabets written like I and D. So let me explain the legends here. The table uses four categories: shared independent, shared dependent, CSP owned, and CSC owned. These categories apply differently across SaaS, PaaS, and IaaS models.
Exactly, Akshay. And of all these controls, I want to highlight specifically two shared dependent controls. Those are CEK03, data encryption, and CEK08, key management capability. These controls are particularly important because they require collaboration between the CSP and CSC. For example, CEK03, while the CSP provides encryption capabilities, the CSC must properly implement and manage encryption for their data. And CEK08 provides the CSC with the ability to manage their own encryption keys, bring your own keys effectively. The CSP must provide the capability, but it's up to the CSC to implement the capabilities provided by the CSP to protect the CSC sensitive data. In both cases, success depends on both parties fulfilling their responsibilities. It's a partnership where both the CSP and CSC play vital roles in ensuring data security and compliance.
Now that we have covered the basic of shared responsibility, let's dive into the specific roles of CSPs and CSCs in implementing cryptographic controls. CSP have a crucial role in playing the groundwork for secure cryptographic practices. They manage the underlying infrastructure and provide the necessary tools and services. This includes secure key storage, encryption capabilities, and configurable security features.
That makes sense. How do CSPs ensure they're meeting industry standards?
Well, CSPs are responsible for aligning their security services with industry best practices and regulatory requirements. They need to comply with standards like FIPS and NIST, and specifically FIPS 142 and 143. And for NIST, it's SP 800 and SP 853. Additionally, they offer compliance frameworks and tools, conduct risk assessments, and keep the cryptographic system up to date. So the CSP provides the secure foundation for CSCs to use. So, Kerry, can you explain about what are the CSC's key responsibility in conjunction with CSPs?
Sure. Well, as you mentioned, the CSP provides a secure foundation. CSPs have an equally important role. They need to actively engage with the tools and services provided by the CSP. It starts with defining roles and responsibilities for cryptography and key management within their organization. CSCs are also responsible for encrypting sensitive data before uploading it to the cloud, as well as managing their own encryption keys when leveraging the customer provided encryption keys.
That's quite a responsibility, if you see. Are there any ongoing tasks for CSCs that needs to be handled?
Absolutely. The CSCs need to implement their own cryptographic risk management processes and utilize the configuration options provided by the CSP to establish strong cryptographic processes and change management within their implementation.
It sounds like there's a real partnership between CSPs and CSC when it comes to cryptographic security.
Exactly. It's this shared responsibility that ensures comprehensive security in cloud environments. The CSP provides the secure foundation and tools, while the CSC actively uses these tools to protect their data and applications. Both parties need to fulfill their roles for the system to be effective. So let's discuss some of the risks and implementation best practices for the CEK domain. So historically speaking, one of the primary challenges organizations have with encryption is managing the lifecycle of their encryption keys. CSPs solve this problem by offering managed encryption and key management services via the CSP's Key Management Service, or KMS for short. This capability for a CSP to manage the lifecycle of encryption keys on behalf of the CSC can result in increased operational efficiencies and considerable cost savings for CSC. Next, we're exploring an interesting case in Fintech cloud security. So a fintech startup, CSC, made a significant shift. They migrated from their customized third-party managed tokenization solution to a commodity cloud-based service, leveraging the CSP's key management service, the KMS. The result, an impressive cost savings of over $500,000. This is huge for a startup. And in addition to the annual cost savings, this move addresses multiple internal risks at the CSC. So let's break them down. First, there's the risk of key compromise. If the keys are compromised, the company could lose the ability to de-tokenize sensitive information, a critical issue in finance. Second, there are operational risks. Any disruption of the service could lead to data exposure or operational downtime, both potentially catastrophic for a fintech. And lastly, there's the risk of vendor dependency. By relying on the custom third party for this crucial function, the CSCs put in a lot of eggs in one basket. So to mitigate these risks, we look to the cloud control matrix. 3 controls are particularly relevant here. CEK03, data encryption, CEK11, for key purpose, and CEK08, CSP key management capability. Now let's talk about some of the best practices for implementation. Leveraging a CSP's STAR level 2 tokenization service can significantly boost operational efficiency and slash compliance costs. This is a major upside for CSPs. CSPs address their CSC's tokenization challenges by offering managed services. This provides a robust, scalable solution. For those handling sensitive data like cardholder data for PCI DSS, tokenization could substantially reduce their PCI DSS operational responsibilities. This is a game changer for many fintech companies. And finally, the benefits of leveraging the CSP's cloud-based tokenization service in terms of cost savings, efficiency, and reduced compliance burden are substantial. The key is in clearly defining and understanding the roles and responsibilities for the CSC and CSP as defined in the CSP SSRM. Akshay?
Thanks. Thanks for that great real-life example, Kerry. Now let's take another scenario related to healthcare data, which is like one of the most crucial area where we are storing very confidential information. Imagine a healthcare analytics startup that making waves in the industry. They're using a single cloud platform to store and analyze patient data from multiple hospitals, a common setup in today's digital landscape. Now they are doing some things right. They're using CSP managed encryptions and they're rotating their keys on an annual basis. Plus, they have logically segregated each customer data in a separate databases with probably unique identifier. Sounds pretty good so far, right? Well, here's what where it gets interesting. Despite these measures, there are several significant risks we need to address. First, let's talk about data security. The company is using single encryption key for all their data. This creates a single point of failure if that key is compromised. All customer data is at risk. Moreover, annual key rotation might not be frequent enough for such sensitive data, specifically for PHI data. Next, we have the issue of inadequate data isolation. While the company has logically segregated the data, they lack customer-specific encryption controls. This is not only possesses a security risk, but also makes it challenging to prove the data segregation to auditors or compliance officers. Speaking of compliance, this setup potentially falls short of HIPAA and high trust requirement. In the healthcare industry, compliance isn't just nice to have, it's absolutely critical. So how do we address these risks? Let's look at some key CCM controls that can help. We can start with CEK02 and CEK03, which covers roles, responsibility, and data encryption. CEK04 ensures we are using appropriate encryption algorithms. CEK12 addresses key rotation, which is critical in this scenario, and CEK08 focuses on key management capability used by the customers. Now, let's deep dive into some best practices for implementation to make this startup scenario a little bit more secure after this. First and foremost, we need to use customer managed keys, or in short, CMKs. For each client database, we need to use customer managed keys. We should rotate these keys biannually, at least for PHI data, which is more frequent than the annual rotation in our scenario, which is kind of important when you consider PHI data. Next, we need to establish the robust role-based access control and maintain a detailed audit logs. This addresses both security and compliance concerns. Third, we need to ensure short encryption for both data at rest. And third, we need to ensure strong encryption for data at rest and in transit. This includes employing field-level encryption for sensitive PHI data, providing granular protection. Fourth, we need to align our practices with HIPAA and HITRUST. This isn't just about ticking boxes, it's about creating a comprehensive compliant security posture. Finally, we need to implement continuous monitoring and regular security assessment. In the fast-paced world, healthcare data, we cannot afford to be reactive. By implementing practices, our healthcare analytics startup can significantly enhances its posture, better protect patient data, and align more closely with the industry compliance requirement.
Thanks, Akshay. As we wrap up today's discussion, let's recap on the key takeaways. Implementing cloud security isn't a one-time task, but an ongoing process. The implementation guidelines can be used to implement controls from scratch or enhance existing ones. The CCM mappings provide a roadmap across multiple frameworks that can be used to navigate the complex landscape of cloud security. Understand the security responsibilities that are shared with your CSP. It's critical for CSCs to understand those responsibilities that are partially shared with their CSP and to implement cloud services according to their CSP's guidance and the defined requirements or responsibilities for each party. Leverage the CAKE to conduct regular assessments of CSPs or require CSPs to be STAR Level 2 certified. Lastly, CSP managed encryption lifecycle management and tokenization services. It can be a game changer and significantly reduce cost, reduce risk, boost efficiency, and lead to substantial cost savings.
And don't forget the importance of customer managed keys for sensitive data in regulated environments, specifically the government data or PHI data. They can help meet compliance requirements while still benefiting from CSP managed services. Remember, effective cloud security balances control, convenience, cost, and compliance. By applying these principles, you are not just securing data, you are enabling your business to thrive in the cloud. And thank you very much.